So today, a warm welcome to our HODs, faculty members for today's Paricharcha session. So today we will be having three sessions. The first one is a journal paper presentation followed by an open forum discussion on the topic privacy concerns related to digital footprints and a book review. So first we will be having journal paper presentation by Ms. Mani ma'am. So I invite Mani ma'am for the paper presentation.
The B represent service probability in, last out, or sometimes we will face a priority-based customer arrivals. Okay? The next C is number of servers. C will represent how many servers are there to provide the service. T is the capacity of the system, which means it may be happens that there is only one server which will provide the service. So this is the capacity of the system, how many customers can arrive at a time in the system. Now E represents the Q, discipline, FIFO, LIFO, priority base. In this research paper, my model is GOG system, which represents GOG is geometric arrival process, in which we have considered that at least one job is must mandatory in one slot. Now what is slot? Slot, we can say that if we have a and these are the slots. Suppose in a real life we take an example, if a customer arrives in between 1 p.m. to 2 p.m. So this is the slot of 1 p.m. to 2 p.m. So अगर एक slot present है, तो at least एक customer will arrive. This is geometrical geobase. Here G represents journal service process, in which process we will provide the service to the customer, that is journal probability distribution. Or 1 represents the server which provide the service to the customer. So there are the keywords which we have included or studied in the paper. The first one is discrete time system. It is a device or algorithm that according to the well-defined rule operates on a discrete time signal called input signal, or we can say the customer or a request is arrived, to produce another discrete time signal called output. Next one is waiting time. So the time which we have to wait in the line for the service is a waiting time. So it is a time up to which a unit has to wait in the queue before it is taken to the service. Next is queue. Queue is a waiting line. Next one is queue size. The queue size is, it is defined by the number of customer waiting in the line. Next is masses. We have used the terminology masses in this paper, which doesn't mean that it is a kind of a masses. It reflects that it may be a customer, it may be a request for service. Okay. Next one is FCFS, is first come first server. This is a machine or a service provider which provides the service to the customer when the request is generated. Now last one is late and early arrival. So my basic work is to find out the difference between waiting time and queue theory in late arrival model or early arrival model. So we will explain what is late arrival model. So if this is the NX slot, this one is the whole NX slot, and if the customer will arrive at the end of the month, this is late arrival model. And if the customer will arrive starting of the slot, this is early arrival model. So we have to find out the difference between waiting time and the queue size. Basically हमें इसमें find किया है हमारे इस पेपर में that अगर late arrival होता है किसी भी कस्टमर का, तो waiting time क्या सेम रहेगा अगर वो early आता है, या फिर queue size भी वही सेम रहेगा अगर वो late आता रहेगा early. इसका difference हमने इसमें find किया. तो the first objective is to compare the waiting time distribution of random masses in a late These are few symbols which we have used in our equations. First is mu. This represents the service rate. At what rate the service will be provided to the customer. Lambda will be the arrival rate at or we can say number of jobs, number of packets, or the number of customers arriving in a unit time in that NL slot. Next is WQ. It is a waiting time in the queue. Next is LQ. This is the length of the queue. This one is rho, that represents average server utilization in the system. Next is circumflex. This is number of arrivals in the slot, which comes identically distributed. I represents the inter-arrival time between one arrival to next arrival. मतलब एक arrival जब आया और next arrival उसके बाद जब customer आया उसके बीच का difference will be I. This ln represents queue size immediately after the NS slot. This circumference with Z is a generating function of the number of arrival in the slot. These three are the generating functions of different situations. The generating function is helpful in considering the situation when we apply a certain kind of situation to the model. जैसे अगर मैं ये कहूँ कि मेरे मॉडल में सिर्फ एक सर्वर होगा, that means सर्विस रेट उसका थोड़ा सा स्लो होगा, राइट? अगर वही मेरे पास सर्वर 2 हो जाए या फिर फाइनाइट हो जाए या फिर इनफाइनाइट हो जाए तो ऑटोमेटिकली जो सर्विस प्रोवाइडिंग का रेट है वो हमारा इंक्रीज होगा, राइट? तो वी विल फाइंड आउट these equations by the use of generating functions. Next is this one. Tu is the probability generating function for time t that a message is played in the system. T represents at what time, कितने टाइम कस्टमर सिस्टम में आने के बाद सर्विस लेने के लिए उसको कितना टाइम लगा, that is t. Q में तो कितना रहा, that is different time, waiting time. पर जब सिस्टम में वो एंट्री की और जब वो अपना प्रोसेस कंप्लीट कर रहा है तब उसको कितना टाइम लगा, that is t. Next one is WG. This is virtual waiting time. U is unfinished work, and the last one there is the arrival of message in the NS. So these are the calculations which I have done in my paper. This one is a generating function. With the help of probability generating function, we will find the TZ. Now this one is the condition which we have used in our model. That is ln with the queue size immediately after the NX slot. मतलब NX slot के खत्म होने के बाद जो queue बचा, जो customers बचे वो उसकी queue size है. तो यहाँ पे 3 conditions हैं. जब NX slot में कोई भी कस्टमर अराइव नहीं कर रहा है और length of a queue is 0, then the length of n+1 will be equal to the circumflex distribution. Now the second one is if ln will be 1 or greater than 1 with no completion service, with no service completion in the n+1 slot, then the equation will be this. And if the service completion is also done with length of q1 or greater than 1, the equation will be this. So by using these equations, these all equations we have found through the MATLAB. MATLAB is a type of software by which we gave all the conditions of a model and they will generate the equations and find out the results. These all are the equations. So this is the table which is generated by the MATLAB, which represents this one is a number of arrivals of a message or a customer or a service during each slot. That can be n+0, n+1, n+2. This is a random variable. We change the value of t. The slot will be 1. These two are the conditions which is finding out. And when we compare the nth slot with the n+1 slot, most of the observations are equal. Most of
the last one, size of cube. So in the table, which figure is giving you this? No? The third conclusion, where we are saying irrespective, no, if the person is early arriving to the previous slot, the queue size will be smaller in comparison to if the person is arriving in the next slot. So which figure is depicting this thing?
From this, the last one will be the situation.
Okay.
Yes. And the above one will be the current almost equivalent situations. And last, my references. These are some references which I have been using.
Good presentation, I say, because I don't understand the formula given, but I could get the concept. So well explained. Thank you.
And to little money, at least I recall my maths from 98 now. The way you explain, we could understand what these things are. I tried to simplify it.
So if we talk about the complexity of this paper, where it will fall in the scale of 1 to 10, 1 being the least complex, 10 being the most complex.
This paper,
Yeah.
according to this paper, इस मेरा सबसे पहला पेपर है जो मैंने PhD में रोल किया था तब किया।
And this is your PhD thesis?
Yes, PhD.
Okay, okay.
This is my PhD.
And do you get enough of the adequate numbers of the papers for the queuing body?
Queuing and operations.
Few of the jargons I could understand because they've been used in accounts and finance, but of course not related in reference to
U and lambda.
that was I know before all these things. Yeah, there